about that. Okay, the original line was y equals negative 2/3 x plus 2. So the slope of that line was negative 2/3 because that's the coefficient of the x, which means that the slope of my line, the slope of line number 2, is going to be the opposite reciprocal, because that's what happens when you have perpendicular lines. So I have to flip this negative 2/3 over and change its sign. So this is negative, I'm going to make it positive, and the 2/3 will become 3/2. So for the line that's perpendicular to this original line, my equation is going to be y equals 3/2 x plus b. And I still have to figure out what the b is. Now they did a little trick on this. They told us what the x-intercept was. They didn't tell us what the y-intercept is. I can't say that b is -4 because -4 is the y-intercept. But what does it mean that the x-intercept is -4? It means that it's crossing the x-axis at the point -4, 0, where the x-intercept is the y is 0, where the y-intercept is the x is 0. So I know a point on this line. I know the point -4, 0. So I'm going to replace the x with -4 and the y with 0, which will give me this equation, 0. I'm going to put it with 0/1 because I'm putting everything over 1 so that we don't mix up our fractions and our whole numbers, equals 3/2 times -4/1 plus b/1. I just put my whole numbers over 1. And the first thing I have to do is multiply the 3/2 by the -4/1. And I see that the 2 in the denominator is canceling into the -4. That is giving me -2. So this is giving me 0/1, which is just 0, equals 3 times -2, which is -6/1, which is just -6, plus b/1, which is b. And all I have to do is now bring the 6 to the other side. So it turns out that my b is equal to 6. So now I have both pieces. I have that the slope is 2/3, the m is 2/3, the y-intercept, the b is 6. So here's my equation. Y equals 3/2 x plus 6. That's how you would do that example. How to write the equation of a line where we know it's perpendicular and we happen to know a point on it. The x-intercept was a point. I know this is confusing. I find that a lot of people find this one of the most confusing parts of the term. If you're still having a hard time with it, when either a little bit later, I'll stay longer. If anybody wants to ask me a personal question about what I did here, or if anybody wants to ask me a question right now, please. Any questions? How many people got?
Yeah, I have a question.
Sure.
So going back to when you got 0 equals -6, to get the -6, before you got 3 times -2, what did you do like before that? Did you cross multiply?
No, okay, let me erase this over here. Let me put it over here, okay? I had 3/2, right? Times -4/1. That's what you're questioning me about, right?
Yeah.
Now remember how you multiply fractions. First of all, if you want, you're supposed to have a calculator. You certainly could stick this into your calculator just by doing, in your calculator, 3 divided by 2, because that's how you get a fraction, times, use the little x for the times, -4. If you did it on your calculator, you have a calculator, Caesar?
Yeah.
Try it on your calculator. You'll
But
see, what do you get when you multiply 3 divided by 2 times -4?
you get the -6. I just wanted to know like how you like
Okay,
did you cross multiple
so
without the calculator? Did you cross multiple?
okay, so I was going to say, when you want, why am I telling you with a calculator? Because sometimes you're under time limit. And if you want to do it with a time limit, then you want to do it as quickly as you can. So getting used to using your calculator for these type of things makes sense. But let's explain why that works. When you are multiplying two fractions, the rule is to multiply the tops together and to multiply the bottoms together, which gives you 3 times -4, which is -12, over 2 times 1, which is 2, correct?
Yeah.
And can I reduce this?
Yeah.
-12 divided by 2 is -6. You do not cross, you do what's called cross cancel. You could have done it this way. You can cross divide. You can't cross multiply because it's not an equation. You can divide the numerator and denominator by the same thing. And if you notice, you can divide the 2 by 2 and get a 1, and the -4 by 2 and get a -2. And then you get 3 times -2 equal -6 directly. So either one of those ways would have worked. Is that clearer to you?
Yeah, thank you.
Okay, any other questions? Was anybody able to get this whole thing done? You're definitely going to have probably 2 problems on the test with these. Let me remind you that the test is going to, great. Carmelita, thanks, great. Let me remind you that starting at around 2 o'clock, I will open up the test on Delta Math, and you are to do, there are going to be 10 problems. Now, if you get a problem wrong, you can do another problem. You won't get full credit, like you, instead of getting, let's say each question is worth 10 points because there are 10 questions. If you do one wrong and you do the next one, you'll probably get 9 points. So you can keep trying. If you got the question right and you try to do another problem of the same sort, it'll tell you you can do more problems, but you won't get extra credit for doing more problems. So go to your Delta Math, you'll see it listed, it'll be something like Test 1 for Math 136, something of that nature will be the name of it. All right, unless there are any questions that anybody wants to ask me about what might be on the quiz, I'd like to go on to the second question that I had written on the board. Okay, let me write it back on the board for you so that we can do that problem. That'll take us into what we're learning today, which is systems of equations. And the question I had written on the board was this. I want you to solve graphically the system of equations. X plus y equals 3 and x minus y equals 1. Okay, I'm going to give you time to try those while I go and see who else joined our class. I'll give you about 5 minutes for that, and then we'll go on to doing that example. Okay, I think we can get started on this now. I want to show you how we're going to graph this graphically, how we're going to graph it and solve it graphically. And then I'm going to go into showing you ways of solving these, not graphically, but what we call algebraically. Okay, so if we want to solve this graphically, let's call this equation 1 and this one equation 2. And when we want to graph them, we could graph this. It looks like it would be good to try it, graphing it by the intercept method. Remember, to find, let me see if I can do it this way. I'm going to put number 1 is x plus y equals 3. And here's going to be equation 2, so I can work underneath it, which is x minus y equals 1. So if we want to do it by the intercept method, which is usually, when it's set up in what we call standard form, makes sense, we'll find the x-intercept by letting y equals 0, which will give me 0 plus y. I'm sorry. Letting y equals 0. X plus 0 equals 3, which gives me x equal to 3. In other words, here on my graph paper, for number 1, the x-intercept is the point 3, 0. When the y is 0, the x is 3. 1, 2, 3, 0. Here's the x-intercept for the first equation. To find the y-intercept, we'll let x equal to 0. In that case, we'll get 0 plus y equals 3, which gives me y equals to 3. In other words, the y-intercept is the point x0, y3. Here's that. 1, 2, 3. So if I connect these points, here is line number 1. We've drawn the graph of line number 1. That was very easy to do, so let's do this one by the intercept method as well. Because again, it's not put in the y equals mx plus b form. Remember, those were the two methods that we usually used. Either the slope-intercept method, if it's written in the y equals mx plus b form, or the intercept method. Let's do the intercept method for this one as well. So to find the x-intercept again, we're going to put y equal to 0, which will give me x minus 0 equals 1, which means x equals 1. The x-intercept is the point 1, 0. So here is 1, 0. This is the x-intercept for line 2. What about the y-intercept? To find the y-intercept, we again have to let, just like we did before, x equal to 0. And if we do that, we get 0 minus y equals 1, which is negative y equals 1. And if I divide by negative 1 to get the y alone, I get that y equals negative 1. In other words, the y-intercept is the point 0, negative 1. So here's 0, negative 1 is right here. So if I connect those points, I get line number 2. And remember, when it says solve the system of equations, what it means is, where are these 2 points crossing? What is their intersection point? And if I look at it, it looks like the x is 1, or the x is 2. This is really, it should be, and again, I have this problem because I'm not on a, I don't have a piece of graph paper, and this is very inexact. This really should be more, a little bit more over here like this. This is where the 1 should be. Should be more like this. That's a better picture. Here is my point of intersection. And I have to read what that point is. Well, to get to that point, I first have to go 1, 2 to the right, and then I have to go 1 up. So the point of intersection is the point 2, 1. Therefore, the solution to this system of equation is 2, 1. Now, when we write the solution, we can either write it as an ordered pair, or we could write it separately. We could say x equals 2, y equals 1. Either method of writing the solution is acceptable. If you're writing it as ordered pair, remember you have to put it in parentheses with a comma in between them, and the first number always has to be the x number. Notice it really works because 2 plus 1 is 3, and 2 minus 1 is 1. So this really works, this value. It's called the point of intersection. It's the point, the ordered pair that works in both equations. That's the solution of our system of equation. Remember, when they meet and at a single point, they're two straight lines. They cross at a single point. That's what's called a consistent system of equations. Is that clear? Does anybody have any questions about this? Don't worry, I went back and I looked at the attendance again for those of you. At the end of the period, I will go through the people that I have not marked here. I'll just read their names. If you came in late, I will change you to present. If I don't read your name, it means that I saw that you were here and I marked you present. Any questions about anything else? Okay.
I just need to take a picture of that, please.
I'm sorry?
I just need to take a picture of that, please.
You I'm having a hard time understanding what you said. All I heard was please.
No, I just wanted a picture. I got it. Thank you.
Okay, great. Oh, okay. All right. If you noticed, it wasn't a terribly hard problem, but it took a lot of work. Solving systems of equations graphically is time-consuming. Not only is it time-consuming, unless you're doing this very carefully on a piece of graph paper, it's very easy to mix up a 2 with a 1. You saw I really had to fix it up because it didn't come out too exact. So, and on top of that, what if they would have given me a little bit harder example where the numbers didn't come out to be whole numbers like 2 and 1, but 1.56 and negative 3.7. There's no way I would have been able to get an exact answer in that way. So obviously doing it by graphing it points out exactly what you want to do. But there are two simpler methods that we can use that don't involve any graphing and yet will allow us to find the answer to the system of equations. So let's start with the exact same system of equations. I'm going to erase all the work that I did, and I'm going to show you a method that doesn't involve any graphing that is called it's given two different names. The method can either be called the elimination method, or sometimes it's called the addition method. Depending on which textbook you're looking at, or which, sometimes Delta Math calls it elimination, and our textbook will call it addition, but they mean the same thing. They're the same method. How does this method work? Let's take the exact same set of system of equations. The x plus y equals 3, and the x minus y equals 1. And I'm going to show you how the elimination method works in this case. We're just going to do it without graphing it, without drawing any pictures. We're just going to do it what we call algebraically. What I'm going to do is I'm going to add the two equations down. Notice when you have two things that are equal, x plus y equals 3 is one set of things that are equal. X minus y equals 1 is another set of things that are equal. If you add equal things, your answers are going to be equal as well. So let's add these two equations down. I can do that as long as I've lined up my x's and my y's and my equal signs and my numbers. And that's exactly what I have when I have the standard form of the equations. So adding the first x plus x, that gives me 2x. Plus y and negative y cancel out. The y's are eliminated. That equals 3 plus 1, which gives me 4. So the point of adding the equations is that when you add them, you eliminate one of your variables. That's why it's called the elimination method. We added it, that's why it's called the addition method. Again, it doesn't matter what you call it. Notice once you've eliminated one of the variables, you get a simple equation with just one variable that you can solve because you just have x's here. So if I divide this by 2, this will give me x equals 2. It right away gives me the correct answer for x. But when I'm solving a system of equations, it's not enough just to give the answer for x. You have to give the answer for y as well. So the way you figure out what the y is, you go to either one of your original equations and substitute in the number that you know the x is. Replace, let's say we're doing x plus y equals 3. That's our first equation. I now know what the x is, so I can substitute the x for the x too, and I get 2 plus y equals 3. And now I can solve for y by just bringing the 2 to the other side, and that gives me y equals 1. And again, we now have our solution, x equals 2 and y equals 1, which again, we could have written this way, or we could write as our ordered pair 2, 1. Notice we came to the same conclusion, except we did it algebraically, and it was much quicker, and I didn't have any problems trying to read the answer. So if you want to do something more efficiently, probably this is the method that you would like to use. Now, let's try another one. I'm going to try to do one more, and then I'm going to give you one to try on your own. Again, unless it tells you specifically to solve the equations using the graphing or graphically, you can use the algebraic method. Okay. Suppose I had given you this example. Two x plus y equals 1. X minus 5y equals 17. And I want to solve, this is again a system of equations. Each of the examples again are written in what we call the standard form. X, y equal number. X, y equal number. Well, if I did what I did before and I just wanted to do the addition method, if I just added these two equations down, look what would happen. I do 2x plus x and I get 3x. And I do y and negative 5y, which is negative 4y, equals 1 plus 17, which is 18. Unfortunately, when I add these two equations down, I am not eliminating any of my unknowns. I still have an x and I still have a y. The whole point of adding the equations before was when I added them, one of the variables was eliminated. We got rid of one of the variables. So just adding the systems of equations down doesn't always work. So let's go back and think, what would it have taken in order for us to eliminate a variable? So let's just decide which variable we'd like to eliminate. And we could do this arbitrarily. You can pick, I want to eliminate the x's, I want to eliminate the y's. Let's today decide that we want to get rid of the x's. We want to eliminate the x's. Well, think about it. When you add to the equations down, what it'll take to eliminate the x's is that the numbers in front, their coefficients should be the same, except one should be positive and one should be negative. In other words, if I had a 3x, then I'd need a negative 3x to eliminate it. If I had a 10x, then I'd need a negative 10x to eliminate it. In order to eliminate one of the variables, that variable in the two equations has to be the same coefficient, but one has to be positive and one has to be negative. So I have this method. It's not always the simplest method, but it's a method that always works. There might be easier numbers to use, but this set of numbers will always work. What we're going to do is we're going to multiply each of the equations by the opposite coefficient. Remember, we wanted to eliminate the x's, so therefore the coefficient on the second x is 1. I'll multiply the top equation by 1. The bottom equation, I'll multiply by the 2. I multiply the top by the bottom coefficient. I multiply the bottom by the top coefficient. And then I think about the sign, the positive or negative sign. In this case, both of these numbers are positive. But in order to eliminate, when I add, I need one to be positive and one to be negative. So therefore, I'm going to multiply one of these by a negative. So when I decide what I'm multiplying my equations by, I first worry about the number without any sign. And secondly, I worry about, should I use a negative or should I not use a negative? Now look what's going to happen. If I multiply the top equation by -1, that'll give me -2x minus y equals -1. I am distributing this -1 to each term. The second equation I'm multiplying by 2. So I'll do 2x. 2 times negative 5y is negative 10y equals 2 times 17, which is 34. So I have multiplied the top equation by a negative 1, the bottom equation by 2. Remember, every single term has to be multiplied. You have to distribute it. Now let's see what happens when I add these two equations. I add negative 2x plus 2x, and they cancel out. Well, that's not surprising that we forced it to happen. We said we wanted to eliminate the x's. So we knew as soon as they had the same coefficient, but one was positive and one was negative, when I add it, it'll cancel out. Then I add the y's. This is a negative 1y and a negative 10y, which gives me negative 11y. And then we have negative 1 plus 34, which is 33. And to finish this, I just divide both sides by negative 11. So it gives me that y equals 33 divided by negative 11, which is negative 3. Again, if the numbers are more difficult, just take out your calculator and do it with your calculator, though 33 divided by 11 is not very difficult. We're not completely finished with this because we haven't gotten the value for x. In order to find the value of x, I take one of my equations. I'm going to take the first equation. It doesn't matter which one you do, but I'm going to take the first equation and substitute the negative 3 for the y, because now I know what y is. So this will give me 2x minus 3, because y is negative 3, equals 1. And solve this equation, because now we can solve it. We don't have any x's, any y's in this equation. We just have x's. So we get 2x equals 4, and I divide by 2, and that gives me 2 as my answer for x. So my answer becomes x is 2, y equals negative 3, which I could have also written just as an ordered pair, parentheses, 2, comma, negative 3. So either this way or this way is acceptable. Notice again, we've done this system of equations without any graphing. These would not be so easy to graph. This certainly would be difficult to graph, but we have solved the system of equations. If we would have graphed it, they would have, the point where they would have met was a point 2, negative 3. We have solved the system of equations. Just to show you that it's totally arbitrary the way I pick getting rid of the x's, I'm going to do the exact same problem again, but instead of eliminating the x's, I'm going to eliminate the y's. After we've done that, I'm going to then let you try one on your own, okay? I'm going to erase the problem because now I have to look for it again. Sorry. Here are the two problems. 2x plus y equals 1. X minus 5y equals 17. Same exact question, but instead of eliminating the x's, we're now going to eliminate the y's. I just want to show you that it really is totally arbitrary. If I want to get rid of the y's, Then I look at the coefficients. Again, I just look at the numbers. This has a coefficient of 1. This has a coefficient of 5. Forget about the minus. We're just looking at the numbers, not at the signs. So that means if I want to get rid of the y's, I'm going to multiply the top equation by the 5 and the bottom equation by the 1. I multiply them by their opposite coefficients. Now I think about the sign. If I notice, this already has one sign being positive and one sign being negative. The signs are exactly the way I want them. I want one to be positive and one to be negative. So therefore, I'm not going to use a negative when I multiply. I only have to use a negative if I have to change a sign. I don't want to change any signs. So I'm going to just use the positive numbers. Multiplying the two equations, the top equation by 5, will give me 10x plus 5y equals 5. Don't forget, every single term multiplied by 5. The bottom equation stays x minus 5y equals 17. Now when I add them, I'll add the 10x and the x. That'll give me 11x. The 5y and the negative 5y will cancel out. That was the whole point of it. We said we wanted to eliminate the y's. The 5 plus the 17 gives me 22. And now I can solve for x by dividing both sides by 11. And again, I get x equals 2. And go back to one of the original equations. It doesn't matter which one. Let's say the top one. And replace the x with 2. So it'll be 2 times 2, because my x is 2, plus y equals 1. That'll give me 4 plus y equals 1. And therefore, we'll get y equals negative 3. Again, my answer is x is 2, y is negative 3. Exactly the same answer that we had gotten before. Of course, you have to get the same answer. It's the same system of equations. But it doesn't matter if you eliminate the x or the y. It's up to you what you want to do. Again, multiply each by the opposite coefficient. And then if they're both positive or they're both negative, you're going to have to use a negative with one of them. But if one is already positive and one is negative, which is how you really want it to be, then you just use positive numbers. Does anybody want to answer a question before I give one for you to try? Okay, so I'm looking at practice sheet 3. Let's do one of the ones that are on the practice sheet. And I'm looking at example let's look at example number 1. I'm going to put it on the board for you to try. We have 2x. Let me just write it further. 2x minus 3y equals 13. That's our first equation. And the second equation is 5x minus 4y equals 22. Notice they are both written in standard form. If they're not, we have to make sure, if we want to use the elimination method, we have to have the equations in standard form. They're both in standard form. I want you to use the elimination method to solve the system of equations. I'm going to give you a few minutes for that. Okay, I see a few people have sent me the answer in the chat, and they are correct. Let's do this together now. Let's solve this with the elimination method. Let's get rid of the x's. So it doesn't, again, as you saw before, it doesn't make a difference which we are going to get rid of. So here are our two equations. The first equation is 2x minus 3y equals 13. I'm going to multiply that by 5. Which will give me 10x minus 15y equals 65. Don't forget to multiply every single term by the 5. The second equation, I'm going to multiply by the 2. Because I'm multiplying it by the opposite coefficient. But since these are both positive, I'm going to use a negative over here. It wouldn't have mattered if I used the negative with a 2 or the negative with the 5. Just one I leave positive and the other I multiply by negative. That'll give me negative 10x. Negative 2 times 4y is plus 8y equals negative 2 times 22, which is negative 44. And now when I add these two equations down, the 10x and the negative 10x are eliminated. I have negative 15y plus 8y, which gives me negative 7y. And on the other side, I have 65 minus 44, which gives me positive 21. And now I divide by negative 7 on both sides. So that gives me y equals 21 divided by negative 7 is negative 3. Again, I'll go to the first equation. It could be the second equation, doesn't matter. And replace the y by negative 3. So it's 2x minus 3 times negative 3 equals 13. 2x plus 9, negative times negative is positive, equals 13. And I'm going to subtract 13 from both sides, which will give me 2x equaling 4. So x equals 2. So my solution is x is 2, y is negative 3. As a bunch of you have answered. Okay. Let's go on to another method that we could use to solve the system of equations. Most likely, if you're going to solve a system of equations, you're going to use this elimination method. But every so often, the example is set up in a slightly different fashion, and we can use something called the substitution method. Let's see how the substitution method works. Taking a different example. Let's say I have this system of equations. here's my first equation, x minus y equals -3. And my second equation happens to be y equals 3x plus 5. The top equation is written in standard form, x, y equal number. But the second equation is the way we usually write something in y equals mx plus b form. It's not in standard form. And I said in order to use the elimination method, I need both my equations in standard form. Now, I could have made this in standard form by subtracting 3x from both sides. I will do that afterwards. I'll show you that that's an alternate method for doing this problem. But in order to use the elimination method, I would have to do something with the second equation because it's not in standard form. But there is a method that we can use that is called the substitution method. Which is a very useful method when we're given one of the equations, it doesn't matter which one, in the format y equals something or x equals something. It doesn't have to be always y equals, it could be also x equals. If one of your equations has either the y alone equaling or the x alone equaling, then the substitution method is a very good method to use. You could use the substitution method in other cases also, but that's usually the most common place where it's used. If you look at this equation saying y equals 3x plus 5, what that equation is telling us is that y has two names. It has the name y, but it also has the name 3x plus 5. Y equals 3x plus 5. Y and 3x plus 5 can be used in this particular problem interchangeably. So if I go to my first equation, x minus y equals -3, which I can't solve because I have two variables, I can remove the y and replace it with its other name, which is 3x plus 5. And the advantage of doing that is that then I'll end up with an equation that doesn't have two variables, it'll just have the variable x. So how do I do that? I do x minus, now I have to put this in parentheses because I want to show you in place of the y, I'm putting this whole expression, 3x plus 5. It's called the substitution method because I'm substituting, I'm replacing the y by its other name, which happens to be, in this case, 3x plus 5. So my equation becomes x minus parentheses 3x plus 5 equals -3. And now I have just a regular algebraic equation to solve. Don't forget when you have a minus in front of a parentheses, it's as if there's a 1 there, and you're going to multiply everything by -1. This will be x. -1 times 3x is -3x. -1 times 5 is -5 equals -3. Combining the like terms, x and -3x is -2x. -5 equals -3. I'll add 5 to both sides. And I will get -2x equals -3 plus 5, which is +2. And when I divide by -2, I will get x equal to 2 divided by -2, which is -1. And now I'll go back, since I know that the x worked out to be equal to -1, I can now figure out what the y is by replacing the x by -1. So I'll get y equals 3 times -1 plus 5, which is -3 plus 5, or 2. So my x is -1, my y is 2. Here's my solution. -1, comma 2. This is what's called the substitution method. Notice neither the substitution method nor the elimination or addition method needed any graphing. It was all done without graphing, just by algebraic means. Do you think you could try one like this on your own? I'm going to put one on the board for you to try.
I have a question.
Let's see if I...
Wait, yes, I have a question.
You have a question? Yes, let me hear your question.
Where it says x minus 1 with the parentheses, how did you get the -1?
Yeah, the -1 wasn't there originally, right?
Yeah, it wasn't there originally.
In place of the y, I put the 3x plus 5, but I had to enclose it in a parentheses because I want the y is the whole 3x plus 5, so I have to subtract this whole thing. Now, how do I get rid of parentheses where there's a minus in front of it?
Oh, okay, all right.
You can put a 1 there. It's as if there's a 1 there. It's an imaginary 1. Or you could just say, well, negative times 3x is -3x, and negative times 5 is -5. You could do it without putting in the 1 there. But sometimes people feel more comfortable. Any other questions? Where did I get? Oh, okay. I answered your question, right? Okay. So now I'm going to give you one to try and see if you could do one of these. Again, you can, I will never tell you, you have to do it by the substitution method or the elimination method. When I will give you a test, I will allow you to use either method as long as you come out with the right answer. And it's up to you to decide which method you want to use. If though I tell you solve something graphically, I will want to see the graph.
Professor, hold on. I need to take a picture.
Okay, I'm standing away. I know I'm a better door than a window, so I better be out of this way.
Thank you.
Got it?
Yeah.
Okay. Okay, let's look at this example. This is example 2 on the practice sheet. The first equation is y equals 4x plus 12. And the second equation is 2x plus 3y equals -6. See if you can solve the system of equations. We're going to do it first by substitution, and then I'm going to go back and show you that you really could have done it using elimination as well. Okay, so I'm going to give you about 5 minutes to work on this. If anybody has any questions, you can ask me. Okay, so I'm going to show you how to do it using the substitution method. And then I'll go back and show you that if you don't like the substitution method, you really could have used the elimination method on this one as well. If you notice, my first equation says y equals something in terms of x. And remember, whenever my equation says either y equals something or x equals something, it looks like a perfect setup for the substitution method. In this case, what we're going to do since it's the first equation that says y equals, in my second equation where I'll see a y, I will replace it with 4x plus 12. I am substituting 4x plus 12 for what y is. So here we have my second equation looks like this. 2x plus 3. Okay, here is my y. For my y, I'm using its long name, 4x plus 12. And that's going to equal -6. And now it's a regular linear equation in terms of x. It's 2x. Here I'm going to multiply everything by 3 using the distributive property. So this is going to be 3 times 4x, which is 12x. And 3 times 12, which is 36. And that's going to equal -6. 2x plus 12x, those are like terms. That gives me 14x plus 36 equals -6. And I want to get rid of this 36, so I'll subtract 36 from both sides. So I'll get 14x equals, well, -6 and -36 is -42. And divide by 14. And -42 divided by 14, if you don't know that by heart, you can certainly put it into your calculator. That's going to give you -3. So it turns out that my x equals -3. And since the y equals 4x plus 12, the y is going to be equal to 4 times -3 plus 12, which turns out to be -12 plus 12, which equals 0. So my equations, the system of equations has a solution -3, 0. It doesn't matter that one of the answers is 0. The x is -3, the y is 0. How many people were able to get that answer? Hope some of you were. You want me to? Okay, great. Do you want to take a picture of it, anybody? Okay. I am going to repeat. I just want to show you that we could have done this exact problem using the elimination method instead of, if you don't like the substitution method, though I think here it's sort of a good setup for it, we could have done it by elimination. Okay, I'm going back and erasing everything I did and doing it by the elimination method. I will come up with the same answer, you'll see. I want to show you that you can make your decision as to which method to use. Again, if it says graphically, you have to do it with draw a picture of the graph. But if it says elimination and you do it by substitution and you come up with this right answer, I will give you full credit for that. I want you to be able to make your own decision as to which way you like doing this better. Now, if I look at the two equations, let's call this 1 and this equation 2. Okay, I'm now calling this, I'm doing it by the elimination method. So I take that off. This equation, equation number 2, is a perfect setup for the elimination method because it's in the standard form. X, y equals number. But the first equation, the equation y equals 4x plus 12, is not in a good format for the elimination method because it's not in the standard form. I need the x to be on the same side as the y. So here's what I'm going to do. I'm going to subtract 4x from both sides of this equation. And I'm going to put the x first because I want it x, y equals number. So this will end up being -4x plus y equals 12. So now I have my two equations. My original equation has become, here's my first equation, has become -4x plus y equals 12. And my second equation is staying 2x plus 3y equals -6. Now I have them both in standard format. X's are lined up, the Y's are lined up, the equal signs are lined up, the numbers are lined up. I must have that if I want to use the elimination method. Let's this time get rid of the Y's instead of the X's. We've always been getting rid of the X's, so let's get rid of the Y's. It doesn't matter which one. If I want to get rid of the Y's, I'm going to have to multiply the first equation I'll multiply the first equation by the 3. And the second equation, well, the coefficient of this y is 1. But since both of these are positive and I need one to be positive and one to be negative, I'm going to make one of these numbers negative. And it doesn't matter if it's the top number or the bottom number, not both of them negative, but one negative and one stays positive. So my first equation, after I've multiplied it by -3, will be positive 12x minus 3y equals -36. And my second equation, when you multiply something by 1, it stays the same. It's 2x plus 3y equals -6. And when I add these two equations together, I get 12x plus 2x, which is 14x. -3y and 3y. There's our elimination. We've gotten rid of our y's. That equals -36 and -6, which is -42. And if I divide by 14, I get x equals -3. Just like we did before. And then I could go to either one of the original equations. Let's go to equation 2 just to show you it doesn't make a difference. I'll get 2 times -3 plus 3y equals -6. So I get -6 plus 3y equals -6. And I'll add 6 to both sides. And I'll get 3y equals 0. And when I divide by 3, 0 divided by anything is 0. So again, I get -3 for my x and 0 for my y. -3 comma 0 as our solution, just like we did before, using the elimination method. Again, it doesn't matter which method you use, just which one you find more comfortable. Okay, I see there are a lot of.
Can I take a picture?
Yeah, sure. Okay. All right. I think we've done a lot of work today. We're almost finished with chapter 3, the chapter that we're doing now, which is systems of equations. We now know 3 methods for solving systems of equations: graphically, elimination or addition, and substitution. Next time, we're going to talk about word problems that we can solve using systems of equations. And then we're going to start chapter 4 as well. Remember, I said starting at 2 o'clock, you're going to be able to access the quiz. I'm going to give you 24 hours in which to complete it. There are 10 questions. It does not include systems of equations. Does anybody have any questions they want to ask me? Also, I will be giving you homework on the systems of equations, but I'm probably going to open it up pretty much immediately for you So the test is going to be called test 1, but the other one is going to be assignment number 4 or homework number 4. Okay? Anybody have any questions? Anybody whose name, who came in late and was not, I see there's somebody more. Anybody here that wasn't here previous? If you just came in now and after I took attendance, please let me know that you're here.
Oh, I was here before, Professor. I was just having connection issues.
Who's that?
Not far.
Okay, then I marked you here.
I'm here. This
And
is
me too.
Samaya.
I was having connection issues as well.
Okay. Were you here when I called the names?
I was not here,
Yeah,
so
but
I
I
don't.
didn't hear mine.
You didn't hear yours, that meant I marked you here. If I didn't call your name, it meant I marked you here. Okay.
I'm here.
Who's
This
here?
is Samaya.
Zanaya.
Samaya.
What's your last name?
Night.
Let me just check that I have you here. Wait a second. You're from 017 or from SEK1? I think you're from
See.
my next class.
Oh, my next. What time does that start?
It starts at 12.
Okay, okay.
This is still the old class. Okay, come back at that time. All right, everybody. Have a good day, and I will see you on Thursday at the same time.
Bye, Professor.
Bye-bye.
Have a good day, Professor.
Have a good day.